Hey everyone, welcome to my YouTube channel. Today we're going to talk about a little bit about vector databases and graph databases. So someone basically asked me outside of this medium, what's a vector database and what's a graph database? And like it was one of those things where I was kind of explaining it, and then I realized, you know what, maybe not many people are aware of this. And I figured like let me come up with a video to kind of give you a high level overview between the two, like some of the negatives, drawbacks, benefits, but also the use cases as well too. But also at the same time, I also figured one thing to add to it, well, is basically it's sort of not an addendum to my prior video about vector databases, but it's more of something to help you understand a little bit more. Now, I should ask that if you haven't subscribed, please subscribe if when necessary. Oh, not please subscribe when you subscribe. If you like the video, please hit the like button, and by knowing what the likes or dislikes, I'll focus on that content more than the other contents that I'm putting out, like with sports related stuff, as well as basically more some of the reality TV shows and everything like that. But in any case, now there are two types of databases. These are two different databases, with vector databases and graph databases, but they're becoming very popular, very very popular, for especially for when it comes to natural language processing and machine learning applications. Now, a vector database, it's a database that stores information in form of vectors. Now, vectors are mathematical objects that can be used to represent any kind of data, including text, numbers, and images. Vector databases or vectors, basically, I think of it like words in a document or pixels within an image. Now, vector databases are often used for like natural language processing or ML applications because they are very efficient for storing and querying the data. Whereas a graph database is a database that stores information in the form of a graph. A graph is a collection of nodes known as vertices and edges, also known as links. You probably see them a lot nowadays. Nodes can represent entities such as people, places, or things. Edges represent a relationship between entities. Graph databases are often used for like social networking, fraud detection, and recommendation engines as well. Too. We start seeing those more often than not in Netflix, as well as Facebook and Twitter and such. The other factor is like maybe TikTok a little bit. Now you're seeing a little bit more towards the vector database, or gearing towards the vector databases as well too when it comes to recommendation engines. Some of the benefits now of vector databases is that they're very efficient for storing and querying text data. This is because vectors can be used to represent the meaning of words and phrases, as I mentioned, and this makes a vector database ideal for like NLP, natural language processing, or ML, machine learning applications, such as machine translations, sentient analysis, or even question answering, which is what you're seeing nowadays with ChatGPT and Bard and all that other stuff, bad boys, anyways. The other big benefit for vector databases is they're very, very scalable. They scale very easily, that they can store large amounts of data and you can query against that data very quickly. And because the vectors can be stored in a distributed manner, which makes it possible to store and query very large amounts of data. The other aspect is like the data itself, how it's stored, is usually unstructured per se. And it kind of has a sort of a SQL-like language from that perspective. Now, one of the big benefits, or one of the negatives of vector databases, is like it can be very difficult. Not, I don't want to say to scale per se, but it can be hard to integrate with other databases. They use a different form of data model basically than traditional relational databases as well. I mean, it could probably integrate with maybe MongoDB in ways, but more so, quite honestly, it's a different data model. Kind of, like I said, it's unstructured, but you're starting to see a lot more relational database engines creating extensions. Like there is a vector database or vector extension for Postgres. Now, graph databases, the benefits of a graph database is that they're very efficient for storing and creating relationships between entities. Because graphs can be used to represent complex network of relationships. This makes like the graph databases ideal for social networking, fraud detection, and of course recommendation systems I mentioned. They're very flexible. They can be used to represent a wide variety of data structures. trees, like trees, lists, and sets, if you're familiar in the programming world about that. One of the big negatives, of course, is it's very hard to query. The data may be structured, but the querying language, the graph traversal language, is not as easy as you think it would be to, like, you know, essentially query against that data set. The graphs can be very complex, and it can be very difficult to find the relationships you're looking for. But they're built towards complex queries, whereas vector databases are not built for complex queries. The other aspect is with a graph database, it's not that easy to maintain. Graphs constantly change, and it can be difficult to keep the graph up to date on all cases. Vector databases are often used for, as I mentioned, with MLP and NLP and ML applications. Some of the examples of NLP use like databases like machine translation, sentient analysis, question and answering, spam filtering, fraud detection, as I mentioned. Whereas graph databases can be used for social networking, fraud detection, recommendation systems. Some of the examples, of course, are Facebook, Twitter, LinkedIn, and Amazon and Netflix, of course. These are both two different types of databases, which are becoming very, very popular. As I said, vector databases are efficient for storing and querying text data, while graph databases are, efficient for storing and querying relationship between entities. One of the other factors is as well too is like with the vector database, they're not with the graph database, they're more mainstream. Some of the technologies some of the engines that are out there are a little bit more mature than vector databases. Vector databases are becoming more and more popular because now you're seeing AI models as well as machine learning models that algos that are using it. Querying against that vector database is much more easier to query against essentially. But with that, I'll leave it at that. If you have any comments, questions, please leave them in the comment section. I do respond to them. And again, if you haven't subscribed, please subscribe. With that, I'll leave it at that. Unfiltered, unedited, and unrehearsed. Until next time.